On to the final page of questions for quantitative chemistry on question 5. Tells me about limestone, gives me an equation for breaking down with heat to make calcium oxide plus carbon dioxide. What name is given that type of reaction? You don't really do that until a little bit later on. It's called thermal decomposition, breaking down due to heat. Don't worry too much about that for now. This is very open-ended, blank space, 5-mark question. Calculate the maximum mass of calcium oxide produced when 600 grams of calcium carbonate are heated strongly. In this case, I could actually use the table method if I wanted to. Ratio is 1 to 1 to 1. It's giving me 600 grams of calcium carbonate. It's asking me to work out calcium oxide, so I don't need to worry about carbon dioxide. It's not part of the question. I want to work out the mass of calcium oxide. Step 1 is moles. I have to work out the RFM of calcium oxide first. So that's 40 plus 12 plus 3 16s is actually 100. Therefore, the moles is mass divided by RFM, 600 divided by 100, which is just 6 moles. Using my ratio, 1 to 1 ratio, therefore 6 moles of calcium carbonate makes 6 moles of calcium oxide. Need to turn it back into a mass. Need to multiply by the RFM. RFM is 40 plus 16, which is 56. Therefore, my final answer is 56 times 6, which is 336 grams. Question 6 tells me about a tooth whitening kit. Involves hydrogen peroxide, gives me another equation, very open-ended 5-mark question. Calculate the mass of oxygen produced from 5.1 grams of hydrogen peroxide. So again, I'll use the table method. So a 2 to 2 to 1 ratio. It wants me to work out from 5.1 grams of hydrogen peroxide, which is H2O2, how much oxygen are produced. So it's on this column here. I'm not interested in water in this question. RFM first to work out the moles. Ignore the big 2, it's just for balancing. Therefore, it's 1 plus 1 plus 16 plus 16, 34. 5.1 divided by 34 is 0.15 moles. Using my ratio, it's a 2 to 1 ratio. I have to divide by 2 going this way. So 0.15 divided by 2 gives me 0.075 moles of it. Need to get back into a mass for moles. Need to times it by the RFM. RFM of O2 is just 2 O's, which is 32. 0.075 times by 32 gives me my final answer of 2.4 grams, which is your answer for 5 marks. Question 7. Magnesium sulfate gives me the equation for it. What's the maximum mass of magnesium sulfate which could be formed when 2.1 grams of magnesium carbonate react with sulfuric acid? So it's the whole question start to finish. Again, I'm probably going to use the table method if it's that open-ended. Let's see what I've got. 2.1 grams of magnesium carbonate. So that's the bit here. Ratio, sorry I should have done that first. 1 to 1 to 1 to 1 to 1. Nice and simple one. It's wanting the maximum mass of magnesium sulfate. So it's this bit here I'm trying to calculate. Every other column is irrelevant to this question. Need to get moles of magnesium carbonate first. Needs RFM. Need to work it out. So 24 plus 12 plus 16 times 3 gives me an RFM of 84. 2.1 divided by the RFM 84, moles is mass over RFM, gives me number of moles of 0.025. Use my ratio, but it's just 1 to 1. 0.025 moles of magnesium carbonate must therefore give me the same number of moles of magnesium sulfate. Need to make that back into a mass. Need to times it by the RFM, but I need to calculate the RFM. 24 plus 32 plus 4 16s adds up to an RFM of 120. 0.025 times by 120 gives me a mass of 3 grams. Final answer. Part 2. Student did this experiment, only obtained 1.8 grams of magnesium sulfate. Calculate the percentage yield. So that's a percentage yield question. The equation we've got is percentage yield equals actual yield over the theoretical yield. The actual yield in this experiment was 1.8 grams because they actually carried out the experiment. The theoretical yield comes from the mole calculation, which is 3 grams. To make it in the percentage, I have to times by 100. And if I do that, I get a final percentage of 60%. Suggest why percentage yield is not 100% in this reaction. You've got a few reasons you can put down for that. Loss of the product through transfer. So in other words, you're scraping it out of your beaker and you lose some of it. Side reactions. So in this experiment, it might go in different directions. You might make different products not included in this equation. And the final bit, you might not have actually finished a reaction. Some of the reactants might be left over and haven't fully reacted yet. Final one, question 8. Gives you another equation. Magnesium nitrate breaks down and gives that equation. We've come across that already. Not too important for now. It's called a thermal decomposition reaction. When you have one substance and you break it down into other substances when you heat it. Part 2. Calculate the mass of nitrogen dioxide produced when 4.44 grams of magnesium nitrate are heated. So I'll do another wee table here. So if I look at what I've got 4.44 grams of magnesium nitrate. The ratio across the equation is 2 to 2 to 4 to 1. It wants the mass of nitrogen dioxide, NO2, so ignore magnesium oxide, ignore oxygen as well. Need to work out the moles first. So moles is mass over RFM. Need to work out RFM of this. Ignore big 2 because it's just for the balancing number. So 24 plus, inside this brackets, 14 plus 3 16s twice. Gives me an RFM of 148. 4.44 divided by 148 gives me 0.03 moles. So now look at my ratio. I've got a 2 to 4 ratio of magnesium nitrate to nitrogen dioxide. That's the same thing as a 1 to 2 ratio because I just double to go from 2 to 4. Therefore I need to double this 0.03 to give me 0.06 moles of the nitrogen dioxide. Need to get back into a mass, so I need to times it by the RFM. RFM nitrogen dioxide, ignore big 4 just for balancing. So 14 plus 2 16s gives me an RFM of 46. 0.06 times 46 gives me 2.76 grams of NO2.